So in this video, we are going to deal with the fifth problem. Okay. So here we have got the two polar curves for which we have to show that both the curves intersect each other orthogonally. We are having two methods to prove this orthogonally in the sense that when we find phi1 and phi2, which are nothing but the angle between the radius vector and the tangent. So phi1 is for the first curve and phi2 is for the second curve. So if we take the difference of both, that particular positive value should be equal to pi by 2. If it is equal, then we can directly prove or directly say that the curves intersect each other orthogonally. Second method is basically without finding phi1 and phi2, go for tan. So tan phi1 into tan phi2. If we are getting it as -1, then we can say that the both are intersecting orthogonally. Okay, so these two are the methods to find. Any one you can choose and do. Let us proceed with the question. As we know, the regular thing, first step is basically by taking what? The log on both sides. Taking log. So when you take the log on both sides, what happens? So we'll be doing both the curves simultaneously. So it will be log r is equal to log of 4 secant square theta by 2. Okay. Then next step. For the second curve also same thing. Log r equal to log 9 cosecant square theta by 2. Okay. This is the thing. As we know that when you are considering this, here 4 and secant square theta will be considered as two functions. Okay. Here also same thing, 9 and cosecant square theta by 2 will be considered as two functions. So what we are going to do, we are going to apply one formula for log. Log property we have studied. If multiplication of log of two functions are there, m and n, multiplication of those two functions will give you log m plus log n. So this particular function, this particular property will apply here. So the log r will remain as it is, equal to log 4 plus log secant square theta by 2. Here also same thing, log r as it is, log 9 plus log cosecant square theta by 2. Done. So as we see here, this particular function square is there. Here also square is there, right? That can be applied one more formula. That particular formula is whenever you are getting log m power n. So anything power m, anything power you are getting. So that will be written as n log m. That means that particular power will come in front of logarithmic function. So here also same thing has to be applied. Log r is equal to log 4 plus. Now this square will come in front. It will become 2 log secant theta by 2. I hope you understood here. See this particular thing. Secant square theta by 2 is same as secant theta by 2 the whole square. You can put it as whole square like this. It's the same thing. So it is 2 log this one. Next here also you can do the same thing. 2 will come in front, log cosecant theta by 2. Done. This part also done. So simplification part using the properties is done. Now let us go for the next step, which is to differentiate. So differentiating, and with respect to theta we have to differentiate everything on both sides. Two equations, two polar curves we have to differentiate. So let us go for that. As we know that log r, what is differentiation of log? We know it is log x means 1 by x. Same thing here, log r means 1 by r. So 1 by r you are going to write. But the problem here is it is not with respect to r, it is with respect to theta, right? Theta. So we have to again differentiate that particular r with respect to theta. So dr by d theta equal to, as we know, 4 is a constant. So log 4 will be a constant value. So that particular thing differentiation will be 0. So directly you can write it as 0 plus 2 is a constant value, keep it outside. Log secant theta by 2 can be written as 1 by secant theta by 2, because differentiation of log of something is 1 by that something. But problem again here is secant theta by 2 is there. That particular thing again you have to differentiate with respect to theta. So differentiating this particular thing with respect to theta. Very important step. Chain rule. So it will be 1 by r dr by d theta, again the same thing, equal to log 9, again here constant value, so it is 0, differentiation of that is 0. 2 log cosecant theta by 2, 2 is a constant value, again same thing you have to write 1 by cosecant theta by 2, and again differentiation of that particular thing with respect to, I'll write here cosecant theta by 2, again you have to differentiate. Okay, this is the thing. Now what happens? 1 by r dr by d theta equal to 0 is gone. Okay, fine. So 2 is left out, 2. Now secant theta by 2 differentiation is what? Secant theta differentiation. It is secant theta into tan theta. You might have studied the formula secant x into tan x. So secant theta into tan theta. But the thing is that in place of theta, what is it? Theta by 2. Very important. So tan theta by 2. But tan theta by 2, theta by 2 we cannot write, right? So here also chain rules. See, I'll tell you what happens here. We are differentiating secant theta by 2. So secant theta by 2 differentiation will be secant theta by 2 into tan theta by 2. But in place of theta, who is sitting? Theta by 2. So again you have to differentiate theta by 2. We'll be getting 1 by 2. Very important concept. Chain rule again we are applying. So again we have to multiply here 1 by 2 whole divided by secant theta by 2. Okay. Here also I'll apply. So 1 by r dr by d theta equal to, so 2 into, then differentiation of cosecant theta by 2 we have studied, it is minus cosecant theta cot theta minus cosecant theta cot theta. So what will happen? So minus I'll put in here cosecant theta and cot theta. As I said, theta by 2 is again differentiation 1 by 2 whole divided by cosecant theta by 2, which is over here. Okay. Now cosecant theta by 2, cosecant theta by 2 cancel. 2 from here, from below 2 cancel. Here also same thing. 2 from here, 2 from above cancel. This and this cancelled. What is remaining? Again we have to understand the fact that 1 by r dr by d theta can be written as what? We have studied cot phi. Very important, cot phi. This is what I was talking about. This phi angle is nothing but the angle between radius vector and tangent. So here I'll take phi 1 because two curves are there. One phi 1, other one phi 2. So cot phi 1 equal to what happens? What is left out? Tan theta by 2 is left out. Here also same thing. Cot phi 2 I'll take. What is left out? Cot theta by 2 is left out. Now as we know, we are having two methods to solve this. Sorry, here minus I need there. Okay, be careful, minus. Two methods to solve this, right? Two methods. So the first method is we have discussed that taking the phi 1 and phi 2 value. Other method is by taking the tan. Okay, tan also you can apply. So what happens? I will apply the first method, tan. If I take tan is nothing but reciprocal of this. So tan will be reciprocal of this particular thing. So 1 by tan phi theta by 2. We can write it as cot theta by 2 because reciprocal of tan is cot. Next, here if you come, if you take tan phi 2 reciprocal of this, it becomes minus 1 by cot theta by 2. Now what I am going to do, I am not going to convert it to tan and write. Why? Because what I need to find? I need to find tan phi 1 into tan phi 2, right? So it will be equal to cot theta by 2, this particular thing, into this particular thing, minus 1 by cot theta by 2. This is why I didn't write, because it will get cancelled. This particular thing cancel. Equal to what is left out? Minus is left out, so minus 1. See, we have to show, right? We are not for checking. They are not said to check whether the two curves are intersecting orthogonally or not. After getting this particular, from this we started the first method. Okay, this is the first method. So from this we'll carry out. So cot phi 1 equal to something you got. From this we'll can get the value of phi 1. How to get? See here. I'll write here cot phi 1 you got it as tan theta by 2, and here also I'll write cot phi 2 you got it as minus cot theta by 2. Now I need to get the value of phi 1 and phi 2. So tan can be converted into cot very easily. How to convert tan into cot? Just write 90 minus theta. Cot 90 minus theta. So it will be cot 90 means pi by 2 minus theta means pi by 2 here. This is theta value. Okay. So which formula I am applying? Always remember cot 90 pi by 2 minus theta will be equal to tan theta. Here theta is pi by 2. Okay. So this particular formula I have applied. So here what happens? This cot and cot will get cancelled. What is remaining? Phi 1 value will be equal to pi by 2 minus theta by 2. Done. Next, here you observe, here cot and cot is there. This minus cot theta, I need angle, right? So minus cot theta can be written as cot phi 2 is equal to cot of minus theta by 2. So which formula I have applied here? Always remember cot minus theta is equal to minus cot theta. Okay. So is it necessary to see we are going systematic now. If you cancel also you will be getting same thing. Cot and cot if you cancel, phi 2 value you will be getting as minus theta by 2 only. But we are going systematic way, that's why I have written here. So phi 2 you will be getting cot had got gone. So what is remaining? Minus theta by 2. Okay. Now as we have discussed that angle of intersection, angle of intersection means what? The difference between the two phi 1 and phi 2's. Okay, phi 1 and phi 2 difference we have to take. We will be getting the positive value only. So pi by 2 minus theta by 2 is the phi 1 value. Minus, see here also minus is there. So minus of minus theta by 2. So this particular thing becomes plus. So this and this cancel. What is remaining? Pi by 2 is remaining. So what we have proved? That angle of intersection, this is called as angle of intersection. Okay, this will be using in many upcoming problems. That's why I've said angle of intersection is phi 1 and phi 2 difference. So we are getting it as pi by 2. So we can say that this particular curve intersect orthogonally.